All right, here's the four-step process for solving sample and distribution of sample means. First, identify the problem. Remember, it's ICCI. Identify the problem. C, what are my conditions and what's my choice of methods to solve. And the second C is calculate. Don't forget to show your work. And then the last I is interpret in the context of the problem. All right, let's work on this problem. The number of flaws per square yards in a type of carpet material varies with a mean of 1.6 flaws per square yard and a standard deviation of 1.2 flaws per square yard. The population distribution cannot be normal because a count takes only whole number values. An inspector studies 200 square yards of each of the material, records the number of flaws found in each square yard, and calculates X bar, the mean number of flaws per square yard inspected, in his sample. Find the probability that the mean number of flaws exceeds 2 per square yards. Follow the four-step process. That's our ICCI. All right, remember the first step is to identify the problem. So, what's the probability that the mean, X bar, number of flaws per square yards of carpet is more than 2 flaws per square yard? Remember, the most important thing is to establish your conditions. So we will assume we have a random sample of carpet. That's your first condition. The second condition is there must be more than 2,000 yards of material, which is the 10% rule, 200 yards for our sample times 10. We can use the standard deviation formula, which is the standard deviation of a single item divided by the square root of n. So our new standard deviation for the mean is 0.085 yards. And the third condition is since the sample size is large enough, 200, which is larger than 30, the central limit theorem allows us to use a normal distribution. Alright, your third step is to calculate. Don't forget to show your work, show the Z, show the P, and show the graph. And notice here we're essentially 0. So the probability that X bar, the mean of our sample, is greater than 2 is probability that Z is greater than 2 minus 1.6 divided by 0.085, which is standard deviation, is the probability that Z is greater than 4.71, which is essentially 0, and there's your graph. So for our interpretation, there is almost no chance that the number of flaws per square yard in our sample is more than 2. That is, if 1.6 is the true mean. There you have it, ICCI. Remember, we identified the problem, we checked our conditions, we calculated it, and then we interpreted it in the context of the problem. Alright, you ready for a staring contest? Let's do it. Rachel wins.